Okay, now, guys, we're going to take a rather laborious look at the derivation of the ellipse, working from its definition. Now, the definition is, as you can see here, okay, is the definition is an ellipse is a set of points such as the sum of the distances from any point to two fixed points is a constant, okay? Now, so what that says is here, okay? The set of points, that means this point G, wherever it is, wherever that point G is, anywhere on the ellipse, okay? If I add the distance from G to one focus plus the distance from G to the other focus, that's always going to be the same, okay? So here it is. If point G is any point on the curve, then by definition, as stated here, the sum of the distance GC plus GC prime is always equal to K. And I'm going to show you, okay, with a demonstration here in just a moment, that that constant distance is the length of 2A. Okay, so, and this is discussing that, but I think it's going to be easier for me to illustrate that with a sketchpad model that I did. So, okay, we're back. I'm here with a sketchpad model that I created. I defined this, as you can see, by a set of parametrics, but we're going to actually use this derivation to define this. Okay, so here you can see I have the point B, which is free to move around on my ellipse, okay? My ellipse, the point B can move anywhere on the ellipse. I've clocked the distance B to F1, okay? And I've clocked the distance from B to F2. And I sum them down here. And by definition, as you can see, regardless of how I sweep this around, the sum of those two distances is always going to be equal to, in this case, 10. And what is that length 10? Well, that length 10 is the length of the major axes. It's the length of the major axes. Okay, so we can explain that by sweeping this around to this position right down here. Well, we'll get to right here, but we'll have to move to that in sequences, in a smaller sequence to explain it to you. So I'm going to explain to you that BF2, when down here, is just that distance, okay? In this case, it would be 2 units, okay? BF1 would be, in fact, 8 units, okay? Because it would be running from, as you can see, it's just 8 units there, okay? So that in this position, it's easiest to see that the sum of those two distances is always twice, always 2A, always the length of the major axis. So we're going to come back and work with that a little bit more. But here, this is just showing you, by definition, the sum of the two distances from any point to each of the focus is always going to be equal to twice the A value, or the length of the major axes. Okay, so here we are back again on the PowerPoint slide. Now we're going to go through that derivation. So what I want to show you here is that derivation is going to be a little laborious, but you can look on it through the PowerPoint demonstration. Okay, so for some reason I need this to go backwards. Okay, so here we are. So I've said over here, right here, if I designate this point XY as any point on the circle, then I'm sorry, keeps on moving. Okay, so here's my point XY, any point on the circle. Here's my one focus at negative C comma 0 is the other focus at C0. So D1 plus D2, as we said, was always going to equal 2A here. Okay, so we're going to go through that derivation. And D1 is what? Well, it's a distance formula. Okay, it's D1 is X minus the X coordinate of the focus at 1. quantity squared plus the y coordinate being 0. And likewise, d2 is the distance, okay, to the focus 2, as is illustrated here. Now, okay, we're going to bypass this for a minute and look at that derivation. Okay, so we come back here, as we just stated, that's equal to 2a. All right, it looks a little, you know, it's a little long-winded, but you got to appreciate where it comes from. Okay, so we just automatically seen here, we changed the signs, we saw the 0, so we brought it down to this point. We're going to want to square these to get rid of these radicals, so I moved the one expression to the other side. Now we're squaring both sides. Okay, we're squaring both sides, and this side is squared separately over here, and combining some terms, and we still have a square. So we come down to this point. Okay, and obviously I'm not going through all the steps. You can look at it on the PowerPoint if you're so inclined. But okay, the thing we're trying to illustrate, of course, is that by going through these, by the definitions with the distance formula, lo and behold, we come down to the equation of the ellipse in rectangular form. Quite honestly, as you can see here, I'm not going to ask you to generate this out for me. It's a good exercise. You want to try it. You know, I suggest you do if you want to. Okay. Obviously, it was easier to get this rectangular equation from the parametrics and eliminating the parameter. But lo and behold, we come up with the same thing. Rather long sequence of developments, but there it is for you. Okay. All right. You can enjoy that for yourself on the PowerPoint.